The Chinese experimental reactor East is known as the artificial sun. It's called that because in 2022, the team of scientists working on it came close to creating a source of unlimited clean energy called thermonuclear fusion. It's the same reaction that's kept our sun shining for billions of years. It can also put an end to oil and coal consumption and even stop climate change. But in this video, you'll find out, why can the construction of the most expensive fusion reactor fail? Why does humanity have very little time to study a new fusion method? And most importantly, why should we think twice before switching to fusion power? The pressure in the nucleus of our sun reaches 260 billion atmospheres. For comparison, diamonds are formed out of carbon at a pressure of only 55,000 atmospheres. As a result of fusion on the sun, deuterium and tritium nuclei merge with each other, releasing a tremendous amount of energy. Unfortunately, it's simply impossible to recreate solar pressure here on Earth, but scientists found a way around that. In the East reactor, they heated up nuclear fuel to temperatures many times higher than solar ones, up to 100 million degrees Celsius. For the reaction not to be interrupted and the plasma not to burn the reactor, along with the scientists, it's kept together by a very powerful magnetic field. At the beginning of 2022, the East reactor managed to maintain the right conditions for thermonuclear fusion for a record 17.5 minutes. This is a huge breakthrough. But so far, the reactor is more like a car that you can start for a moment, but it's simply not possible to drive it yet. Meanwhile, 35 countries invested 20 billion euros in constructing the ITER fusion reactor, which will be larger and more powerful than East. For the record, that's nearly all of NASA's budget. If they can finally get more energy from ITER than they spend on heating the plasma and maintaining the magnetic fields, then in 2040, scientists plan to launch the first ever demo power plant with a thermonuclear reactor. But the whole project is also criticized for being too technically complex and unreasonably expensive. However, we still need new, safe sources of energy. Why is burning fossil fuels literally killing us right now? For city folk, all energy is in sockets, but 90% of this energy comes from coal, oil, and gas. When coal is burned, soot microparticles reach the air. They can get into our lungs and cause thrombosis, strokes, and even heart attacks. In fact, hundreds of thousands of people die from fossil fuel burning products every year. And over 10 years, coal-fired power stations emit 55,000 tons of uranium and thorium impurities into the atmosphere. This is more than all the spent nuclear fuel in the world. And if coal seems outdated to you, what about kerosene lamps? 500 million people still use them to light their homes. 77 billion liters of kerosene are burned in lamps every year, while its smoke poisons tens of thousands of people. But this fuel is still relatively clean compared to your usual firewood. That's right, while we're asking Alexa to microwave the toast, millions of people are still cooking food on wood fires. Fires and carbon monoxide take another 3 million lives every year. But no matter what we do, atmospheric carbon dioxide emissions are growing steadily. Over the past 100 years, they've increased by 1.5 times. The problem will be solved once we switch to thermonuclear power plants that will only emit harmless helium as a byproduct. But it'll take 20 years before you can finally charge your phone from a fusion energy socket. And we need to do something about it now. And there might just be another thing that can save us. What energy sources can replace thermonuclear fusion? In just an hour, the sun could give us our annual energy supply. But solar panels are almost useless in cloudy weather and at night. Besides, to get enough energy, we need entire fields of them, and batteries tend to wear out and lose their efficiency. Wind turbines are also not a very good option. They're expensive to build and maintain, birds die because of them, and if it's not windy outside, you won't even be able to charge your phone. But there is another quite unusual source that's often forgotten. I'm talking about geothermal power plants that use the Earth's internal energy. Even just 1% of the energy from the Earth's crust is 500 times more than what we could get from burning all the oil and gas in the world. But here's the problem. Drilling wells in seismically active areas leads to new cracks in the crust, provoking potential earthquakes. In general, the primary concern of alternative energy sources is that their efficiency highly depends on natural conditions. So, does this mean that only thermonuclear fusion will help us escape the suffocating embrace of coal and gas, and which might only be possible in 20 years? Luckily, there's a way out, and it's not in the fusion of nuclei, but in their well-known division. Why can nuclear energy be more efficient than the fusion kind? Nuclear energy is really badly promoted. When people hear Chernobyl or Fukushima, they don't think about a bright future, but about that bottle of iodine pills sitting at home. What if it's just this fear that prevents us from adequately appreciating the benefits of nuclear power? Well, if we consider the most crucial point, performance, the fusion method has the upper hand. A fusion reactor produces 4 times more energy than a nuclear one from a kilogram of fuel. That's 1-0 for fusion. In terms of fuel, deuterium and tritium can be found in seawater, which is in abundance on Earth. But at the same time, there's also more than enough uranium, as used by nuclear power plants, to operate them for quite some time. The score is 2-1. Next, the waste from thermonuclear power plants is dangerous for the next 150 years. In contrast, nuclear waste products decompose in 500 years. 1 point for the fusion team. But in defense of nuclear energy, its waste can at least be reused. But what about their safety? The fusion reactor is highly valued for its automatic shutdown mechanism in case of the slightest mishap. However, today's nuclear reactors also have such technology. Besides, it was the human factor that played a critical role in all those terrible nuclear accidents of the past. Each team gets 1 point here. In the final round, we'll talk about the benefits. With all its advantages, the fusion method has 2 main flaws. Reactors are costly, and there's a high risk of a breakdown because they're really complicated. In its turn, nuclear power isn't as expensive as it used to be, and it's also much easier to maintain. But the most important thing is that the nuclear power plant infrastructure already exists, whereas it'll take 20 years to reach mass thermonuclear energy. And given all the technical and financial challenges, it might forever stay 20 years away from us. And here's the crucial difference. It should be pointed out that right now, good old nuclear energy definitely outdoes trendy thermonuclear fusion. But that certainly won't make us give up on the artificial sun dream. The day for thermonuclear energy may come when we start to colonize exoplanets around other stars. After all, there'll definitely be water, which is the source of thermonuclear fuel. So, the main thing for humanity is not to screw everything up right now.